morning students, I welcome you all for another lecture on the course Microprocessors and Microcontrollers. In today's class, I am going to discuss about a concept, pin configuration of 8051 microcontroller. We know that 8051 microcontroller was available in 40 pin dual inline package. So this is that IC structure. So the pins of this 8051 are arranged in two lines. That's why this structure is called dual inline package structure. The signals from 1 to 10, 1 to 20 present on left hand side. Pin number 21 to 40 present on right hand side. Before starting the signal description, I would like to share one important point about this, that is, this 8051 microcontroller can communicating with external world with the help of these 40 pins, or with the help of these 40 signals, or with the help of these 40 lines. That means these I can call as a signals or lines or pins. We can go and use any one of these three words. With the help of these 40 pins only, the 8051 microcontroller can communicating with the external world. And the second important thing is, if you see this structure, some of the signals have a multiple function. That is, port 0 signal have an alternate function, port 2 signals have an alternate function, and port 3 signals have an alternate function. Once you remember the comparison between a microprocessor and microcontroller, one of the point is related to this. That is, in case of microcontroller, we found more number of signals are multifunctional. So that's why here these signals have more than one function. That statement also satisfies. And another important thing is, this 8051 microcontroller operates in two different modes. One is a single chip mode and second one is extended mode or expanded mode. I would like to talk about extended mode or expanded mode, what this is. Extended mode operation or expanded mode operation of 8051 in the sense, in 8051 microcontroller basic system, we have an external memories are connected to 8051. We know that 8051 microcontroller have internal random access memory of size 128 bytes, internal read-only memory of size 4 kilobytes. Whenever the user feels the internal memory is not sufficient for his or her application, then what a user can do is, user can use external memories. Once external memories are present in your system, that time we can say that our 8051 is in expanded mode or it is in extended mode. Like your 8086, to move the operation of 8051, it is in minimum mode or a maximum mode. There have a dedicated signal that was a pin number 33 MN/MX bar. By using that, we can operate our 8086 is in minimum mode or maximum mode. Such type of provision is not there in this 8051. Only based on a system itself, we can conclude our 8051 is in single chip mode or it is in expanded mode or extended mode. So, by remembering of these few points about this 8051 microcontroller, I start my discussion with pin number 1. If you see here friends, pin number 1 to pin number 8, these 8 signals we consider as port 1 signals. Port 1 signals. These signals are represented like this, P1.0 to P1.7. So these 8 signals we consider as port 1. And you remember friends, these 8 signals are used for the connection of I/O devices, irrespective of your 8051 is in single chip mode or it is in extended mode. I repeat friends, these 8 signals are only used for the connection of I/O devices, irrespective of our 8051 is in single chip mode or extended mode. And one more thing, it is very clear friends here, out of 4 ports of 8051, this is the port which is purely dedicated for the connection of I/O devices, irrespective of mode of operation. So that you have to remember about this. And one more important thing is, this port have 8 signals. These 8 signals you can program individually according to our requirement. That means the user can use P1.0 as an input signal, P1.3 an output signal at a time. By programming of P1.0 as an input signal and P1.3 as an output signal. That means the port signals of 8051 we can program it either as an input signals or an output signals individually, or we can program all the signals of your port 1 at a stretch, either as an input port or an output port. That provision is there. And one more thing is, the internal address of this port 1 is 90H. The internal address of port 1 is 90H. These points you remember, friends, about the port 1. And next, pin number 9 is RST. RST means reset. Now listen, friends, this reset I can also call the reinitialization. I can call reset as reinitialize. Initialize. That means, once again, if you want to get initial conditions of your 8051, initial conditions in the sense, once you turn on your 8051, what are the conditions we identified in 8051? If you want to need those conditions one more time, that time I took the help of this reset signal. That's why it is called reinitialize signal. Once your processor identifies logic 1 on this RST, your 8051 was resets. Once your 8051 resets, that means once your 8051 was reinitialized. So many things that are happened internal to our system. In that, number one is it stopped the current executing program and it shift execution to an initial address whose address is 40H. This is the first thing. Once your 8051 receives logic 1 on reset, your 8051 reinitialize. In that process, what happens? Number one is it stop a current executing program and it shift execution to initial address, which is 40H. That means the initialization program of 8051 starts from 40H onwards on an internal read-only memory, which is a program memory. Once you turn on your 8051 microcontroller, it will go and execute that initialization program. That means by execution of that, it has to prepare itself to do the tasks which are assigned by the user in near future. So that's why what happens, first thing is, once your 8051 identifies logic 1 on reset signal is, it stops current executing program and it shift execution to an initial address whose address is 40H. This is number one. And number two is, all internal registers of 8051 are loaded with their initial values. Don't think, friends, always the initial value is equal to 0. Most of the registers are loaded with a 0 as an initial value. But some of the registers have a non-zero value as initial value. The best example is, once your 8051 was resets, the stack pointer register SP is loaded with the 07H. It is not a 00H. In this case, 07H is an initialization value of a stack pointer register SP. Once you reset your 8051, your stack pointer is loaded with the initial value, which is 07H. It is not 00H. This is number two. So here my second point is, once your 8051 was resets, all internal registers are loaded with their initial values. That means initial values may not be always 0. Most of your registers are loaded with 0, which is initial values of those registers, but some of them have initial value is not a 0. The best example is a stack point have an initial value is 07H. It is not 00H. And coming to the third point is, your 8051 has a 4 ports. Port 0, port 1, port 2 and port 3. These 4 ports are defined as input ports. These are 4 ports are defined as input ports. Once your 8051 was reset. This is number 3. And coming to number 4, the internal buses of our system can be operated at tri-state or high impedance state. That means those buses are not carrying logic 1 or they are not carrying logic 0. They are simply is in logically disconnected state, that is called a tri-state or high impedance state. These are 4 things have happened once your 8051 receives a logic 1 on a reset signal. Or we can see in another way, once your 8051 was a reset, these are 4 operations are performed internal to our system. So this is about pin number 9. Next coming to guys, pin number 10 to pin number 17. Pin number 10 to pin number 17, we consider as port 3 signals. These are port 3 signals. So here the pins are identified like this, P3.0 to P3.7. What I can say about port 1, the same things are applied for port 3. That means each and every port signal of this port 3, we can program either as an input or an output. Or we can program all the pins of this port 3 at a stretch either as an input port or an output port. That is one point. And second point is the internal address of this port 3 is 0B0H. The internal address of this port 3 is 0B0H. These are 2 points are similar to our port 1. Now, one important point regarding to this port 3 is this port 3 is used for the connection of I/O devices only in the single chip mode operation of 8051. I repeat, these port 3 signals P3.0 to P3.7 is used for the connection of I/O devices only in single chip mode operation. But coming to the expanded mode or extended mode, these port 3 signals have different functions. I repeat, in expanded mode or an extended mode, these port 3 signal have an alternate function, that is this. We'll go and discuss these signals in detail, guys. First, I start with the P3.0 and P3.1. Especially, these 2 signals are helpful for me doing of a serial communication. These are 2 signals for serial communication. Generally, any processor or controller supports parallel communication. But your I/O devices, some of them knows parallel communication and some of them knows serial communication. Once the devices knows only serial communication, that instant your controller want to communicating with such type of devices, your controller must know serial communication. If it didn't know the serial communication, then what happens is definitely we must go and put some interfacing device between your controller and that external device. But here there is no need of such type of interfacing device between an I/O device which only knows a serial communication and your controller, because your controller itself knows a serial communication. For a serial communication purpose, we took the help of port 3 signals, that is P3.0 and P3.1. So here the first signal is RxD. RxD means receive data. RxD means receive data. So this is a signal which is helpful for 8051 to receive a data from an external device bit by bit. The device which only knows a serial communication. The device which only knows a serial communication from the device, your 8051 receives the data bit after bit with the help of a signal called RxD, called receive data. That means this signal direction is involved to your 8051. And similarly, the next signal is a TXD, means a transmit data. Transmit data. With the help of this signal, your controller transfer data to an external device bit by bit with the help of this TXD signal. So these are the 2 signals are very helpful to us to do a serial communication in 8051 basic systems. And next coming to next 2 signals. These are 2 signals we consider as interrupt related signals. These are two signals we consider as interrupt related signals. If you remember the features of 8051, our 8051 supports 5 interrupts out of 5. 2 interrupts we consider as external interrupts. What is the meaning of external interrupts? The meaning of external interrupts means the interrupt signals are generated by external devices to our controller. Those interrupts are received by the controller with the help of a signals called INT 0 bar and then INT 1 bar. With the help of this INT 0 bar and INT 1 bar, INT 0 bar means interrupt 0 bar and INT 1 bar means interrupt 1 bar. With the help of these two signals, my 8051 receives interrupt signals from external devices. And you remember friends, at a time there is a chance your 8051 may receive these two interrupt signals at a stretch, but your controller can't provide a service for both at a time. That time what it do is it will provide a service for these interrupts based on a priority. In that aspect, your 8051 give highest priority to the interrupt which is received by the controller with the help of this INT 0 bar. Whatever interrupt your 8051 receives from an external device, by using this INT 0 bar, your controller give a highest priority to it. That means your controller first provide a service for that interrupt. And later on it will provide a service for the interrupt which is received by 8051 by using INT 1 bar. So these two are the interrupt related signals. Next two signals, that is P3.4 and P3.5, we consider as a T0 and T1 in expanded mode. These two are timer related signals. These two are the timer related signals. Again, we remember friends the features of 8051. It has a two 16-bit timer / counter circuits. Once those circuits are act as a counters, the time they need a clock pulse from an external devices to count those clock pulses. The time your controller receives a clock signal from an external devices with the help of this T0 and T1, the time your internal circuits will act as event counters. I repeat, in 8051 there are two 16-bit timer / counters. Whenever they are act as an event counters, the time they are counting the clock pulses which are received from an external devices, those devices send their clock signals to our 8051 with the help of this T0 and T1. These two are the timer related signals or counter related signals. And the next two signals, that is the P3.6 and P3.7, is considered as a WR bar as well as RD bar. WR bar means a write bar and RD bar means a read bar. These are two signals we consider as control signals. These two are the control signals. Once if your controller want to communicating with any external device, either it may send something to that device or it may go and take something from it, which operation it want to perform on the selected device or a selected memory location, your controller has to issue a control signal for it. That is, either it will issue a WE bar signal or RD bar signal. That means your controller want to do a read operation on a selected device or a selected location, that simply it will issues a WR bar. It want to do a write operation. It want to do a read operation, it will issues RD bar. So that these are two signals we consider as control signals. So like this, the both three signals are defined in expanded mode or extended mode operation of 805. And coming to next two signals, that is pin number 18 and pin number 19, XTL2 and XTL1. XTL means crystal connected signals. That means for proper operation of your controller or a processor, we need a clock. Generally for processor based systems or controller based systems, clock signals are produced by clock generator. Generally clock generators are nothing but an oscillators. Coming to 8051, it has an inbuilt oscillator circuit. That inbuilt oscillator circuit is a crystal oscillator. For the connection of the crystal, we took the help of a signals pin number 18 and pin number 19, which is XTL2 and XTL1. We know that our 8051 operating frequency ranges from 1 MHz to 16 MHz. We'll pick only one of the frequency in that particular range for the operation of our 8051. We know that for commercial applications, we can go and use a 12 megahertz clock frequency. That is a theoretical value, but practical value is 11.0592 megahertz. In order to get that particular frequency, we took the help of an internal oscillator circuit, which is a crystal oscillator. It is act as a clock generator. For that, external crystal was connected. For that, we are using XTAL2 and XTAL1. These are pin number 18 and pin number 19. Now coming to 8086 case, guys, it didn't have any inbuilt oscillator circuit. It didn't have any inbuilt clock generator. It is always depends on external clock generator for a clock, which is an IC number 8284. Again, that is also crystal oscillator, guys. Then coming to pin number 20, which is a power supply signal, which is a ground signal. And next, coming to the signals which are present on the right hand side, that is a pin number 21 to pin number 40. So in that pin number 21 to pin number 28, these 8 signals called port 2 signals. These 8 signals called port 2 signals. So what we discussed for port 3, that means these are port signals we can program individually either as an input signal or output signal, or we can program all the port signals at a stretch either as an input or an output, like our previous ports. And the second thing is, it has an internal address, that is 0A0H, but port 3 have an internal address is 0D0H, and port 1 have an internal address is 90H, and coming to this is 0A0H. Now listen friends, these are port 2 signals, that is P2.0 to P2.7. These 8 signals are used for the connection of I/O devices in single chip mode, but it is in expanded mode. The same signals are used as dedicated higher order 8 address lines, that is A82, A50. I repeat, in single chip mode, these 8 signals, that is P2.0 to P2.7, these 8 signals are used for the connection of I/O devices, but it is in expanded mode or extended mode. The same 8 signals are act as dedicated higher order 8 address lines, that was A82. That is about the port 2. Later coming to pin number 29, which is called PSCN bar. That means program strobe enable. Program strobe enable or program stop enable. It is an act to low signal, guys, because here there is a bar over the signal. That means this signal is act to only once. The loss is 0 present over that signal. Now listen carefully, friends. This PSCN bar, that is a program store enable or program strobe enable, is simply act as enable signal for external program memory ROM. I repeat, this signal is used as enable signal for external program memory ROM. We know that our 8051 has internal program memory ROM of size 4 kilobytes, internal data memory RAM of size 128 bytes. Whenever the user feels that is not sufficient for application, then what the user can do is, the user can connect externally another 64 kilobytes of data memory and another 64 kilobytes of read-only memory. So in order to communicating with the external read-only memory, in order to read a code from external read-only memory, definitely that time we took the help of this PSCN bar signal, because this signal is act as enable signal for external program memory. So that is an importance of this. And next signal is ALE. ALE means address latch enable. Address latch enable. So this is the signal which is helpful for us to demultiplex the multiplexed address and data lines AD0 to AD7 with the help of address latches. I repeat, this signal is used very helpful to us to demultiplex the multiplexed address and data lines by using external address latch. Because this signal is act as enable signal for that address latch. Once this signal is active, the incident is the multiplexed address and data lines, that is AD7 to AD0 simply act as A7 to A0. I repeat friends, once ALE is active, that means if ALE is 1, this multiplexed address and data lines AD7 to AD0 is simply act as a dedicated address lines A7 to A0. That means I can say it like this, once ALE signal is active, then these are lines carries valid address. These 8 lines carries valid address. That's why these 8 lines are simply act as an address lines. And coming to the second thing, if ALE is equal to 0, the same AD7 to AD0 is act as a dedicated data lines D7 to D0. That means in every machine cycle, the first operation what my controller can do is it will generate an address. That incident definitely this ALE signal is active. Once this ALE signal is active, then only your multiplex address and data lines are act as an address lines. Then the next clock cycle onwards, in the same machine cycle, the same multiplex address and data lines becoming as data lines. That incident, your ALE signal logic level is 0. It is simply act as an enable signal for address latch. Right? And coming to the next signal is EA bar. Next signal is EA bar, that is nothing but external active or external access. EA bar means I can write external access. External access. Again it is active low signal like our PSEN bar. Whenever your controller want to communicating with external random access memory or it want to communicating with external read-only memory, that incident definitely this EA bar signal logic level is 0. Or this EA bar signal must be active because your 8051 is supposed to both internal memories as well as an external memories. It has an internal data memory of size 128 bytes. And it may support external data memory of size 64 kilobytes. In that the same address may repeats. The same thing is applied for a program memory. Your 8051 has an internal program memory size is 4 kilobytes and it can also support external program memory of size 64 kilobytes. In this case also there is a chance of address repetition. That means what are the 4K addresses we use in internal read-only memory? The same 4K address also we found in external read-only memory. In order to distinguish the generated addresses belongs to the internal memories or an external memories, that is purely depends on the logic level present on this EA bar signal. If this EA bar signal is active, no doubt the generated addresses belongs to the external memories. If this is equal to 0, it is equal to 1, that means the signal is inactive. No doubt that instead the internal generated addresses belongs to internal memories. So final my conclusion about this signal is, if this signal is active, our controller is going to communicating with external data memory or with external program memory. Don't confuse it friend, data memory is nothing but random access memory and program memory is nothing but a read only. And coming to the next, the pin number 33 to pin number 39. These 8 signals, pin number 32 to pin number 39, these 8 signals we consider as port 0 signals. These 8 signals we consider as port 0 signals. Like our previous ports, here also we can individually program each and every signal of your port 0, either as input signal or an output signal. Or we can program all the pins of this port 0 at a stretch either as an input or output port. That is one thing. And second thing is the internal address of this port 0 is 80H. Internal address of port 0 is 80H. Internal address of port 1 is 90H. Internal address of port 2 is 0H0H. And internal address of port 3 is 0B0H. You know this. And again, in a single chip mode operation of our 8051, These are port signals P0.0 to P0.7. These 8 signals are used again for the connection of I/O devices. And in expanded mode or in extended mode, the same signals are act as a multiplexer adjacent data lines. That means these are act as a A7 to A0 as well as a D7 to D0. So these 8 lines will act as our multiplexer adjacent data lines in expanded mode operation of 8051. That means one time incident these are act as A7 to A0, and in some other time incident the same signals are act as D7 to D0. These are the information regarding to our port 0 signals. And coming to the last signal, that was a VCC. It is a power supply signal. And to operation of this 8051, definitely we have to go and apply single power supply, that is a plus 5 volts. Once you are applying plus 5 volts to that 40th pin of our 8051, then and only it starts its operation. So these are the pins which are present in our 8051 microcontroller. I hope friends you understand the pin configuration of 8051 microcontroller. Thank you for patient listening. In the next class I am going to discuss some other topic. Thank you once again for patient listening.